everyone, welcome to this video on reactivity. This is a continuation of the series of periodic trends. So what I have here is a very short video. It's going to be showing the reaction of three metals. Over here I've got my first metal, which was lithium. Then we had over here sodium, and now we're going to see potassium. Let's see which one is the most reactive. I think you've seen this before. Wow, so you can already see there's a difference in reactivity. So what we saw was the following. We saw that the lithium, sodium, potassium, they all reacted with water because what they're trying to do is they're trying to get to lose that one extra electron to become stable. That's why they're so reactive. But we found that the potassium was the most reactive and lithium was the least reactive. Let's check this out on the periodic table. So as we're going down, we have lithium, sodium, and down here it's going to be potassium. As we're going downwards, we notice that the reactivity increases. Why is that? Well, if you look at this, you'll see that as you go down, the outer electrons that we're trying to lose here, this outer electron, it's further and further and further away from the nucleus. So it's a lot easier to remove in elements such as potassium or cesium, and that's why they're so much more reactive. Well, what if I compared sodium to magnesium? Well, sodium wants to lose one electron, magnesium wants to lose these two electrons. So it's a little bit harder for magnesium to lose those two electrons, so it's a little bit harder for it to react. So as we're going across this way, we find that we get more and more reactive. So the most reactive metal, in fact, would be the one way down in the bottom of the periodic table, and that would be francium, way down here. That's the most reactive metal. Okay, so going like this. Now, how about in the other corner? Well, in the other corner, what we have are these noble gases. And what happens with noble gases? No reaction. So they have no reactivity, or very limited reactivity, which leaves us with the other nonmetals. Well, who's going to be the most reactive nonmetal? Fluorine, of course, because it really needs to have one more electron to have a full outer level. And remember, it has its orbital closest, outer orbital closest to the nucleus. Because it's so close to the nucleus, there's extra attraction towards the nucleus here, so it's going to be a little bit more reactive. So what happens is, as you're going this way, you get more reactive. Well, how about going this way? Well, remember, fluorine wants to gain one electron. Oxygen needs to get two electrons. So it's a little bit harder to do that. So as a result, as you're going across, as you need fewer and fewer electrons, it's easier and easier for you to react. So the most reactive element that's a nonmetal would be fluorine. Again, the most reactive metal would be francium. And all of these over here are not reactive. So this is the little note over here. So again, alkali metals, they're the most reactive. They have the lowest ionization energy. It's the easiest for them to lose electrons. Halogens, well, why do they react? It's easy to gain electrons. So they have a very high electron affinity. And noble gases don't react at all. Okay? So here's a little summary that we have. So again, the most reactive metal is francium because it has a very low ionization energy, easy to lose its electron. And fluorine here is the most reactive metal because it has its highest electron affinity. And the noble gases do not react at all. So let's look at some of these trends and see how I might ask you questions on an assessment. So I might ask you something like this. Which metal is most reactive? Would it be calcium or titanium? Well, what you do is you look at how close are they to francium. So remember, as you're going across this way, the reactivity increases. So it looks like calcium is going to be more reactive than titanium. All right. Now, what if I then said, okay, what's going to be more reactive? Barium or calcium metal? Well, the idea is as you're going down, you have the outer electrons further and further from the nucleus, so it's easier to lose them. So as you're going down, you get more reactive. So barium is more reactive than calcium. How about over here in this corner? I might ask you to compare the reactivity of nitrogen and fluorine. Remember, as you're going across, you get more reactive, so fluorine is going to be more reactive than nitrogen. Or I could compare, let's see here, oxygen and selenium. So what's happening, remember, as you're going towards fluorine, you get more reactive. So selenium is going to be less reactive than oxygen. I think you get the idea with the patterns here. There'll be some multiple choice questions to be working on in the textbook. So that's it for reactivity.